Okay, so now let's start with the slides for the module 1, introduction to the networking. Now, the first thing you were talking about the network model. So the purpose of this class is that give you the overview, the introduction about the networking, how they are communicate together, how the computer communicate together, how they interconnect together here. And the first thing you need to know about the network model. And the first definition is topology. And topology, what is topology? Topology is describe how part of the whole network work together, how they interconnect together, how they talk together here. And in the case of topology, they break it down into two types of topology here. The first one is the physical topology, and the second one is the logical topology. And for the okay, so now that one is a model of the physical topology. So when we're talking about physical topology, it defines everything about the location, about the physical location of every device in the network here. So when you look into the physical topology, you see it clearly defines what room it is. So you see for this one you have, let me see for this one here. Okay, so we see it clearly defines what is room it is, right? And it clearly defines what is rack it is and what is cell it is here. So when you think everything about the physical location, it is a physical topology. It clearly tells you what room it is, what the rack it is, and what the sub-rack it is, or the cell it is here. So we see it clearly tells what room it is, right? You have the room it is, and for each room you have many rack here. And if you look on this one here, all of them they call is rack. And for each of the rack, they have the cell on top of that. They can put the device on top of that here. And the second one, remember that for topology, you have two types of topology. The first one, the physical topology, and the second one, the logical topology. The logical topology is to tell you how they interconnect them together, how they talk together. So when you look on the logical topology, you can see everything about the IP address. You have the IP address and the port number. Right? So think about, if you look on the topology here, you have this one is a switch. We talk about what is the switch and what is the router, what is the IP address later in this class here. But for now, you see, when you look on the logical topology, you have information about the IP address. You have the port number. That is a switch. This is a switch. The switch is the device that interconnects the device together on the same network, right? So basically, so for the switch here, for each switch, you have multiple port on that, Right? So we can think about, you have the switch 2690 for Cisco, you have the 24 port on that. And each of the port, you have number on that one. Say you have this one F0/1, this one F0/2. So when you look into the logical topology, it defines you what the port you are interconnect together here. Right? So remember that you have to clearly understand the difference between the physical topology and the logical topology here. The physical topology, everything about physical location, what room it is, what floor it is, what the rack it is, and what the cell it is here. But for the logical topology, everything about the IP address and the port number, right? And the VLAN information also. Now, we're talking about the two major models. When working with the networking, that when we interconnect computers together. So the first one is the peer-to-peer network model. It's very simple. In the peer-to-peer, everything is equal. Everything equal. Every computer is equal, and you interconnect together. So in the peer-to-peer model here, you have no centralized control. You have no centralized control here. That's the thing you see. You have no centralized control because you that interconnect them together equally here. Right? And the computer on the network, they call it the node or the host here. It forms a logical group of computer and user. Each computer controls its own administration, resources, and security. So when you interconnect them with the peer-to-peer network, each of the computer, you have to take the responsibility to control the administration, resources, and security here. And for the peer-to-peer, you have some advantage and you have some disadvantage here. For the advantage, it's very simple compression. You just interconnect them directly together, right? And it's less expensive compared to the other network model. But you have a lot of disadvantage with this one here. The first one is not scalable. Scalable, that means when you want to add more computer, it's very challenging here. It's not necessarily secure and not practical for the large installation here. So we can think about when you have the computer here, two computers, right? You interconnect them together by peer-to-peer. It's very simple. But one thing, you need one more computer here. It's very huge work here, right? It's very complex thing. So how can you interconnect them together? Each of them, you have to have a single cable for each of them to interconnect them together. So for this one, it normally it works in the very simple network. Normally only two computers, right? Okay, so when you look on this example of the peer-to-peer computer, remember for peer-to-peer computer, each computer has the responsibility to control its own resources, right? So you can think when you look on this module here, you have two computers interconnect them together. Directly connect together, and for this computer here, he connect to the printer, and this computer here, he has some file. He has some file to store here. So now, from the server perspective, from the printer perspective, this one is a printer. Is this one a printer server? So think about this one. Is this guy here want to print something? He have to send the request to the printer server here. And the printer allow him to do some action with the printer here. So if you look from the printer server, this one is a server here. And this one is client. Client, that means you send the request to the server. And the server do something and give you the action here. Now, from the printer server, this one is a server and this one is client. But if you look from the file server here, if you look on from the file server, this one has some file. And you think about this one, this computer here, he want to access some file from this computer. He is now a client. Now is client, and this one is the server. Right? So when you look on the peer-to-peer, you see that sometimes you can be client, sometimes you can be the server here. But the most important thing is that you are the one who control everything you have. Right? You are the one who control everything you want to have. Now, so you have two major models. The first one, the peer-to-peer, it's very simple. That interconnects them together. And everyone is the control of its resources here. The second one is the client-server network model. In the client-server network model, you have a server. And one server you can handle for multiple requests from the multiple client here. Right? So you can think about this client also. Every computer here is a client computer. And you see, in order to log into the network, you have to enter the username and password. And actually, username and password, everything here is controlled by the Windows server, by one of the Windows server, and it controls authentication, authorization. Okay, so we can think about this one. That is a model of the client and the server here. So we can think about. For this one, every computer here, they are client. You have the client here. Every computer is client, and they interconnect them together, and it centrally controlled by the server. And the server here, they maintain the domain database about the Active Directory. It stores every information about the username and password, and it gives you the information about authentication and authorization. Right? So we have to remember that you have to know the difference between the authentication and authorization here. The first one, authentication. Authentication, everything about username and password. Right? You have username and password here. So when you enter the correct username and password, you are able to log in the network. That is authentication. But authorization is that to which level you can do with the network here, right? Some of you do very limited authorization. You just very limited show command, But if you are the administrator, you can do everything with the network. Right? So you have to know the difference between the authentication and authorization here. Okay, for the client, the server network model, you have the network operating system. It's responsible for managing client data and other resources. It ensuring authorized user access, controlling user file access, restricting user network access, dictating computer communication rule, and supplying application and data file to the client. So basically, when working with the client, the server is the one who control every rule here. And normally for the server that you have the network operating system installed, normally you have more memory, you have the processing, you have processing power, and you have more storage here. You need more storage here. And it equipped with special hardware, provide the network management function. Okay, so for the client and server application, you can see on every day, you have the you open the web browser. When you open the web browser, you enter the web browser and you enter the address here. So you have enter the cisco.com here, and you hit enter. Actually, you send the request. You send a request from the computer. It send request to the web server here. To the web server. It's a Cisco web server. Right? So you can see in the model of client server, you can see it and on every activity, daily activity here. You can access by the web service. You can work with the file server, or you can work with the email server. Right? You can work in the email server here. Okay, so the network service are the resource of a network make available to its user. It includes application and the data provided by this application here. In the client server application, a client computer requests data or service from the second computer. It is a server. So remember, in the client server, you have one server, and at one time you are able to handle multiple requests from the client computer. You have one server, and you are able to handle multiple requests from client computer. Okay, so that is an example that if you want to access into the site, if you want to access to the sendgate.com here, you go to the web browser, you enter it, it send it request to the web server, and the web server send you with the HTML code for you to display the web page here. Now, you're talking about the network service and protocol. The first definition is a protocol here. Protocol. So what is the protocol? Protocol is a set of the rule. So think about when you involve in the traffic, you have to follow the rule. So when you see the red light, you have to stop. You have a green light, you can able to go. The same with the network here. In order to communicate together on the network, you have to follow the rule. Otherwise, you have the congestion here. You have the crash here, right? So the same, the protocol is everything about the method and the rule for communication between the network device. And you have to agree on the rule here. You have to agree on the rule here. So back then, if you don't have the rule, each of the vendors, they have their own protocol. So we think about, you have a computer IBM here, and you have a computer with Cisco here, and each of them, they are proprietary. And they are not able to interconnect together because each of them follows specific rule here. Right? That's why you have the standard for the protocol here. You have the protocol is a standard rule, and you have to follow whenever you want to involve in the any communication here. And you have the two primary network protocol in the network here. The first one is the TCP, and the second one is the IP. TCP is the transmission control protocol. Actually, it is a set of protocol here. It is a set of protocol. You have a lot of protocol for this one, and the IP also. And you have some of the popular client server application. You can have web service. You have email service. You have the file transfer service here. You have database service, or you have remote access service. And also we have the domain name system service. We'll talk about what is DNS service later on this class here. That right now is that As that, remember that you have some of application you include the client server. Here you have the web, you have email, you have DNS, you have file transfer protocol, you have database and remote access service here. Now that is the example specific for the email service. Right? So think about this one. If you want to send here, you are the one who you compose the email and you want to send it to your friend here. So this one is sender and this one receiver here. So in order to send the email, you have to involve multiple protocols in the process from the sender to the receiver here. You have the SMTP and you have a POP or IMAP here. SMTP is the simple mail transfer protocol. SMTP here. SMTP is a simple mail transfer protocol. Okay, so SMTP is when you want to send out the email, right? So we'll see if you want to say if you want to send from the computer you want to send it to the Gmail here, right? So receiver is email. Think about you are working with Yahoo Mail here, Yahoo. Right? So first thing here, if you are working with Yahoo Mail, the first thing you have to send from the computer to the email server. This one is Yahoo server here. Right? So whenever you want to send from the computer to the mail server, you have to use the SMTP, simple mail transfer protocol here. And now this guy here works with the Gmail, right? That's why you have to forward the email from the Yahoo server to the Google server here. To the Google server here. So in order to send from the one server to another server, again, you use the SMTP here. Right? So now the email already in the email server. This guy here want to read it, want to read the email. He have to use the POP or IMAP here. POP or IMAP. The POP and IMAP is that the difference between the POP and IMAP is that for the POP, when you read the email, actually it downloads it to the computer and it deletes in the email server here. And for the IMAP, you just read it from the email server directly. You don't download into the computer. That's why for the IMAP here, you're able to read it from multiple times from multiple devices here. But when working the POP, actually when you read it, it downloads it into your computer and it deletes from the server here. That is the only difference between the POP and IMAP. But you see that is an example only, and you see that in the case if you want to send the email, it has to involve a lot of protocol. You have to involve a lot of rules between from the sender to the receiver. Okay, I think this one. Any idea for this one? Which of this protocol could not be used to access the server nearby building? Telnet, a remote desktop protocol, transport layer security, or secure shell here? It's not much information so far, right? I don't know why they check the knowledge here, but not information so far. But let me tell you something here. Telnet, you have the Telnet here, and you have Edge here, and remote desktop protocol. All of them, it is a remote access protocol. So think about if you are stay from home here, you are stay from home and you want to access it to the server from the office. Right? So in that case, you have to use a remote access protocol, and all of them, Telnet here, remote desktop protocol, and the secure shell, they are remote access protocol. That means you can access it remotely to the network device here. And the transport layer security here is the thing that could not be used when you access the server nearby by the meeting. Now we talk about the thing is that you have something about we talk about the topology. Remember that you have the physical topology, you have logical topology, right? And you talk about the model you have two type module here. You have the peer-to-peer, and you have a client and server here. And talk about protocol, everything about the set of rule. When you want to involve in every communication, you have to follow the rule here. Now you talk about the we talk about the network hardware here. So in order to interconnect them together, in order to interconnect the computer, the network, the device together, you have to use some of the network hardware here. So if you look on this one, you can clearly see that you have some of the laptop, you have some of the printer, you have the server, you have a Windows computer here, and you have Ubuntu desktop here. All of them, they are computer, they are end device. But in order to interconnect them together, you have to use a network device here. Or this one, sorry. You have to use the network device for this one here. The switch. The switch is the device, the network device that interconnects computer, the device together on the same network. You have to remember that on the same network only. On the same network. That is a switch. And the switch, you have the multiple port. You have multiple port, and if that plug in the cable here, you see you have the port here, and each of device you can connect it to the port of the switch. And remember the switch, that it is a network device, interconnects device on the same network together. Now we talk about the LAN and the hardware. What is the LAN? LAN is a local area network. You see, that is a local here. The definition tell you what is it? It's a local area network, and usually contained in small space only. That is because it's a local. It's contained in small space only. And the switch is the one who receives incoming data from one of its port and redirect it to another port or the multiple port here. Can you think about the switch here, right? On the switch, you have the multiple port here, and each of the port you connect to the computer here. You connect it to the computer here. So think about this one. You have computer A and computer B here. So in the case that you want to send the information from the computer A to the B here, you have to send it to the switch here. And the switch knows that if you want to send it to the computer B, he knows that he has to forward and he has to redirect the traffic from the port number 1 to port number 5 here. And he redirect traffic from the port number 1 and interconnect with the port number 5 and send it to B. Okay? So just remember for now, you just remember that the switch is the one who receives incoming traffic here. Receive incoming traffic from one of its port and redirect to another port. Redirect to another port. And sometimes you have to send it to every port. That is in the case of broadcast or the multiple. We're talking about it later here. Okay. So in the case of the switch interconnect them together, the physical topology in this network is called star topology. Star, that means you have the centralized device here. That is the switch. That is the switch. And it interconnects every device together with the switch here. So that's why they call it is a star topology. Star topology because you have one central device and every device interconnect them together by using the port of the switch here. Now we have another definition. It is a network interface card. So network interface card is if you have a computer, you have a laptop, or you have the iPad, everything. In order to access to the network, you have to use a network interface card here. Network interface card is a network port used to attach the device to a network, and so called the network adapter. And the network interface card here is everything is stored of every information about IP address or the MAC address here. We talk about what is IP and what is MAC address later. But is that for now, you have to know that in order to access to the network, you have to use the network interface card here. Right? And for a LAN, you can have the one switch or you can have the several switch here. It's interconnect them together by several switch. And the backbone is a central conduit that connects the segment, a piece of the network together. Right? So you have the many types of switch. So if you are the enterprise, if you work in the enterprise environment here, you have the huge you switch here. You see, you have many ports on that one. You can go up to the 1,000 port interconnect the 1,000 device together. But if you're working on this class here, you can see on the data center here, you have this kind of port here. It has Cisco 2960, you have the 24 port, and you have the 24 port. And if you're working with the home router, if you see nowadays you have the home router, you have very small port, small switch here. So if you're working with the home router, you're talking about the home router here. Home router. Actually, the home router is the device. It has multiple functions here. It can be the router and it can be switch on top. You see, if you have the home router, you have some of the port, right? You can have the 4 port, and you able to connect them together with the maximum of 4 wide connection here. Okay, so now you have the network hardware is the network interface card here. You can see you have the laptop, right? You have laptop on that one. You have the network interface card here, or if you have the desktop, you can see when you open it, you look on the PCI slot here. You have the network interface card here, and the purpose of this one here, you see, the purpose of network interface card is store everything about address, and we learn about the address later. And normally you have the 2 types of address. You have the IP address and you have the physical address here. And if you look on this one here, you can see you have the sum of the physical address or media access address here. And it uniquely defines what is your network interface card ID. And it uniquely global wide. Okay, so in the case that if you have the network that you can expand it from the one building to another building, you can use more than one switch here. Right? So basically, if you have very small network here, you have small network, you can have only one switch. You can only need to one switch and interconnect together. But if you want to interconnect from the multiple computers together, you can use more than one switch here. You can have one more than switch. And this one is a backbone. This one is a backbone network here. Now, you talk about the switch. You already talked about the switch. Remember that the switch, let me tell you again, the switch here. The switch is a network device. Interconnects the device together on the same network. On the same network. That is about the switch. Remember that on the same network only. We talk about what is on the how is the same network, or how is it as a network here. Now we talk about the router. Router is a router is a device that manages traffic between 2 or more networks. So if you want to interconnect the network together, you have to involve the router. The router is sometimes we call the gateway here. Gateway. So we think about this one here. If you think about the home network, right, the Soho network here, normally you have the router here, and on the router it also have the switch here. So you interconnect many computer together on the home network, or you can use a wireless communication here. Right? So see about this one. If you want to interconnect together from the one computer to another on the same network, on the home network here, you can go to the switch. The switch is redirect traffic, right? Interconnect the computer on the same network together. So in the case that you are on the same network, you need to involve switch only. You don't have to use the router here. But the thing here, if your computer here, he want to go to outside internet, definitely you have to use the router here. And the router is the one they call it the gateway. You can think about the gateway, that whenever you want to outside the network, you have to involve the router. The router is the gateway to go to the outside network here. You can think about for the class here, you have the gateway, you have the door. You can think about this is the router here. Right? So whenever you go beyond the network, go to the outside network, you have to use the router here. Okay, so now, for one thing you have to remember is that the switch interconnects device on the same network. And the router is the one who interconnect network together. Right? So if you have one network and you have another network here, and in order to communicate together, definitely you have to use a router here. Router is the interconnect network together, and the switch is interconnect device on the same network only. Now, talk about the sum of the function of the router here. The first thing, interconnect the network together. Right? Now, okay, think about this one. If you are the think about this one. You are here. Right? There's a computer here, and you want to send the email. You want to think about you are here in Bloomington, Indiana here, right? And you want to send an email to your friend in San Francisco here, right? So think about this one. In order to deliver the email from your computer to your friend here, you have long way to go, right? So you can go to the Indianapolis here, you go to the hub Missouri here, and you go to the router in the San Francisco here. But the thing here, to deliver the email from Bloomington, Indiana to San Francisco, you have more than one way to go. All right, so normally you can go to the Indiana, but instead of go to the Missouri here, you can go to the Atlanta or any other hub here. Right? So we can think about the same when you drive from here to Chicago. You have many ways to go. Right? So here, now we talk about this one. It is a router. The first thing here, router interconnect the network together. That is the first function of the router. The second one, the second function of router is tell you which way is the best way to reach that destination. Right? So you can think about this one. It have a lot of computation here, and tell that in order to reach to the San Francisco, it's this way. You have to 200. You have to spend for 200 magic here. But for this one, you have 150 here. So we know that this one is a better way. Right? So for when we're talking about the router, you have to remember that you have two functions here. You have two major functions. The first one, interconnect the network together. The second one, it always tells you what is the best way to reach destination here. Right? That is the two function of the router here. Okay, and you can think about the router is like a gateway. Whenever we want to go out, right? You have to involve the router here, and between the network that belong to or more the local network here. Remember here, you see the switch belong to only the local network. It only interconnects the network on the same network here. But when you go to beyond the network, you have to involve the router here. Any questions so far? Yeah. Do you think I need to slow down or speed up? Just let me know.
No, you're okay.
Okay, thank you. So if you look on the topology here, the first one is a typical network. Right? The first one you see is a typical network here. Everything here, you see, it is interconnected together by the switch. They are LAN here, local area network here. Right? But you see, in order to go to the internet here, you have to use a router here. Right? Because you see, if you just interconnect from this computer to this computer here, if you want to communicate from this guy to this guy, you just need to involve switch only. You don't need a router here. But see, if you want to go outside the internet, you have to involve the router, because only the router is the one to tell you to interconnect with the other network and tell you which is the best way to reach the destination here. Okay, now you look at the second one here. That is a typical SOHO network here. SOHO is small office or small home network. That is the more typical you see at the home here. Right? So in the home here, actually you have the device here. At the same time, they are combo device. They are the switch and the router, and they combine them together into one single device. So at the same time, you interconnect them together. It is a switch function here. Right? And the second one, it is a gateway. If you want to go out, it will go to the gateway here. So normally in the home network, you can see the router, actually you have the both of the function of the router and the switch here. That is, remember that. But when you look on the enterprise network here, they have to separate it. you have a huge switch here, and you have dedicated router here. But for the small office and home office here, you can use a combined. You can use a combo device here. It works in the function of both of the switch and the router. Now we talk about the LAN already, right? The LAN is a local area network. It's very small network. And now we're working with we talk about the WAN and the MAN here. The WAN is a wide area network. It's a group of LAN that's spread over the wide geographical area. So the name tells it all here. You see that is the wide here, and it's spread over the wide geographical area. You can think about here. You can think about you have this guy here. Everything about Ivy Tech, Bloomington here. And that is you can think about this one is local area network here, or campus network. Now you want to interconnect every Ivy Tech campus together. So we have the Ivy Tech here, Indiana here, Indianapolis here, right? Indianapolis. So see, this one is a local network, and this one is local network, and you need to interconnect them together. Right? So in that case here, it expands to the wide area network here. This one is Bloomington, and this one is Indianapolis here. It's a wide area network, right? And you interconnect them together. The thing is that when working with a wide area network here, normally you have to involve internet service provider here. Right? You have to you have to list the transmission between the Bloomington and Indianapolis here. That's why normally for the wide area network, you have to involve the internet service provider for the transmission. You cannot maintain your own because it's too expensive here. It's too expensive if you have the long way transmission. Right? So normally you have to list it from the internet service provider. And normally, if you list it from the internet service provider, you can share the same transmission here. You can share with the same with many other companies. Now we talk about MAN. It's a metropolitan area network. It's a group of connected LAN on the same geographical area. It's the same known as a campus area network here. Okay, so MAN and WAN often use a different transmission method and media than LAN. So normally for the LAN, it's very easy for you to interconnect the fast Ethernet cable. Fast Ethernet, you have the 100 megabit per second here. But when you interconnect from Bloomington to the Indianapolis here, you have to list transmission from the ISP. And the more bandwidth you need, the more money you have to pay here. And you have some kind of the other network is the personal area network. It's a very small network here. You can have network of personal device, a smartphone or computer or smart home nowadays. Right? Or you have other network type. You have body area network. You have tiny sensor. You have the storage area network, or you have wireless local area network. That is a definition about the network. And normally you have to remember that normally you have to know what is the LAN and what is the WAN here. Okay, so if you look on this one here, it is a MAN here, right? Sorry, it's a WAN here. WAN is the interconnection, the LAN in different geographical area. So we can think about this one here. Right? I can think so it already tell here, right? Everything here is a network from the San Francisco. And this one is Philadelphia here. And in order to interconnect them together, you have to use the transmission from the internet service provider here. Now, you're talking about protocol already. Protocol is a set of the rule. Whenever you involve in every communication, you have to follow the rule. Otherwise, you have the congestion, you have to crash here. Right? So in the case of the network, they have the two types of the model. You have the two types of the layer model here. The first one is OSI model. You have two type model. OSI model. The second one, you have the TCP/IP model. So for the OSI model, it's open system interconnection. It's a reference model, and it breaks it down into 7 layers. It breaks it down in 7 layers. And for TCP/IP module, it actually is a module you use for every internet communication here. And for TCP/IP module here, sorry, TCP/IP, you have the 4 layer only. This one you have the 7 layer, and this one you have 4 layer. And this one is the one he used in every internet communication nowadays here. This one is reference only. Okay, so let me go over there. Okay, now if you look on the 7 layer of OSI model here, on the left you have the OSI model, and on this one here you have the TCP/IP model here. Now, if you look on the OSI model, you have the you have the 7 layer here. You have the 7 layer here. You have the physical layer. You have the data link layer. You have network layer. You have transport layer. You have session layer. You have presentation layer, and the application layer here. And remember that each of layer you have many protocols. And remember that protocol is a set of the rule here. You have to follow the rule. And the reason that they break it down into the layer, because each of a layer is independent. Right? So something wrong with this one, you can confine it into this layer, and you can do something with this layer. And also the second one, you see back then that every vendor, every company, they have the proprietary device. The thing about, you have computers IBM here, and you have the computers Cisco here. You are not able to communicate together because each of them, they have the proprietary rule here. Right? So now for that reason, they have standard. They have to come up with the standard rule. Everyone has to follow the standard rule. So in the case you follow the standard rule, you are able to communicate together. Right? That's the reason they break it down into layer, and they define every specific rule for each of the layer. Right? So now you should remember that for the OSI module, you have the 7 layers. You have physical, you have data, you have network, you have transport, session, presentation, and application here. And to make it short, you can remember about the phrase here. Please do not throw sources. Away. So see, you have please at P here, sub application. That's right, physical layer here. D here is data link layer. You have throw the T here. You have N here is the network layer. You have T here is transport. Source it at here is a session, and P here is a presentation, and away is application. So that is the way that you want to remember about 7 layers of the OSI model. You have physical, you have data link, you have network layer, you have transport layer, you have session, presentation, and application. And each of the layer, they have specific rule for each of the layer. So think about when you look into the physical layer and data link layer, physical layer, everything about cable here. What type cable and how many pin, what type connector it is. And in the case of data link layer, you have everything about the physical address, and the network layer, and everything about the IP address here, how you route on the internet, and so on. You have many definitions for this one here. Okay, so now you see on the OSI model, you have the 7 layer, and the TCP/IP model here, you have a 4 layer, and this TCP/IP module, it is the one who used in the internet communication here. So when you matching them together, you see the data link layer and the physical layer from the OSI here, the same with the network interface in the OSI module. The network here, the same with, actually this one is not network, this one is internet here. Internet. And the transport, the same with transport. And 3 layer here, session, presentation, and application. It's the same with application layer in the TCP/IP model. Now we go to into the detail of every layer here. The first one is application layer. The application layer describes the interface between the two applications on the separate layer. Application layer, everything interface with the end user here, right? So when you open the computer, you want to send the email or you want to go to web service, everything interface with the end user. Right? Application layer used by program into two categories. The first one provides a service to end user, interface with the end user here. You can have the web service here. Or utility program that provides service to the system. That's simple network management protocol here that you want to monitor and gather information about the network traffic. And you have the definition about the payload here. The payload you see a lot in this class here. The payload is the data. It is the data that passes between the application or utility program and the operating system. That's the payload. Whenever you pass it out from the layer to layer, from the application to application, they call it the payload. Okay, so first thing, application layer, you can think about that is a top layer and interface to the end user here. Now, the second one, the presentation layer. Presentation layer is responsible for formatting, compressing, and encrypting data in the way that receiving application can read. So you can think about you have the formatting, you have the JPEG information, PDF here. You have everything. You have to follow standard. That is a PDF format, right? Or you can compress data, or you can encrypt data. Everything here is encryption, and to make sure that the receiving application able to understand it and able to read it here. Now we have the session layer. Session layer it describes the data between the application, how it sync and recover its message not arrive intact at the receiving application here. And you have the transport layer. Transport layer is responsible for transporting application layer payload from one application to another here. And you have the you have two main transport layer protocol. The first one is TCP, and the second one is UDP here. And we learn about TCP and UDP later on this class. But right now, you can understand that TCP, everything is that you have to check if the data received or not. You have to check that this data received or not, or they call it a connection-oriented protocol. And UDP, you just send it out. You have no guarantee here. You have no guarantee here. So we can think about this one here. If you want to send, say you have the sender here, and you have receiver here. So think about it. If you want to send the email here, if you want to send an email from the sender to receiver here, or you send the data, and normally you cannot send the whole data at one time. Normally you have to break it down. You have to break it down in multiple segments. They call it a segment here. Segment. So in the case TCP here, it is connection-oriented protocol. That means before you send from sender to receiver, you have the handshake. You have the handshake from the sender and receiver. You have to agree that how many data, how many, and when. You send it out. They send it out here. So you agree that at the same time I can send about 100 megabit per second. You have to agree. If you send more than 100 per second here, what happens? The receiver overload and he is not able to handle it. That's why they call it connection oriented. You have to agree everything before you send from the sender to receiver here. And you maintain something is called is sequence number here. So say you break it down, you have the number one, number two, number three, and number four. You see, on the long way from the sender to receiver, sometimes it's not coming in the right order. Sometimes you receive number two first, number one, number four, and number three. So in the case of the TCP here, you have to reorganize it into the original order. So you have to reorganize 1, 2, 3, and 4 here. And the reason that you are able to reorganize it because you maintain the sequence number mechanism here. That's why you see the TCP here is reliable. And before that, you have to handshake, you have connection-oriented protocol. You have to agree between the sender and receiver. But when we're talking about UDP here, UDP, he doesn't care. Just send it out, just send it out, just send it out. He doesn't care if they come in the right order or not. He doesn't care if this guy is unavailable to receive it or not. He doesn't care. Right? So it depends. It depends on the application here. If you need something reliable, you have to use the TCP. The thing about you want to send the email or you want to surfing the web service here, you have to use the TCP. But you need something very fast. I think about voice over IP or video online. You have to use the UDP here. You have to send it out, very, very fast, but no reliable here. Okay, so one thing about this one, you have the definition here. You have to understand the definition of the header and the encapsulation itself. It's very, very important in the network here. You have to understand the definition of the header and encapsulation. So what's the header? Header, it is a control information that you add in the beginning of the payload. Now think about this one. I think about this one here. For this one here, you have the email here, right? You have email here. You break it down in multiple segments here. And for each segment, you have to add the header on that. So header here, you can think header is everything about the control information. Right? You add it before the payload here. You can think about header here, it is a sequence number 1 or number 2 and number 3. That's all to identify which segment it is. Right? So remember, the first thing is the header. Header, it is the control information. You add it at the beginning of the payload. You see, if you have the payload here, header is everything. You put it before the payload, and that is the control information. You have many types of control information here. Right? The second one is encapsulation. Encapsulation, that you encapsulate it into the envelope here. So you can think about you have the one segment here, right? And you put it into the envelope. In the envelope here, and in the envelope, you have information about the control information. So the process, you put the payload and you put the header into the payload. That is the encapsulation. Right? So right now, you have to understand the definition of what is the header and what is encapsulation. Header is the control information you put at the beginning of the payload, and the encapsulation is the process of adding header into the payload before you send it down to the another layer here. Now talk about the layer 3 layer. Sorry, the layer 3 is the network layer. Network layer is you have some of the principle here. The first one is that interconnect the network together. It's the router here. The second one is tell you which is the best way to reach destination here. And in the network layer, they call the data here is a packet. They call the data here is a packet here. It's a packet here. Now you have the data link layer. The data link layer is best for special layer. The data link layer is the only layer you have both of the header and trailer. So normally for every other layer, you only have the header only. But for the data link layer or layer 2 here, you have the both of the header and layer here. Trailer. Yeah, you have both of the header and the trailer for the data layer here. And the data layer is to maintain everything about the media access control address or the physical address here. And each of the network interface card, you have the unique media access control address or the physical address. Now, the last one is a physical layer. Physical layer is everything about the physical, NETI, right? What kind of cable and what kind of conductor you use here? Can you have the sending the bit via the wire or wireless transmission here? It can be the wavelength in the air, voltage on the copper wire, or light if you use the optical cable here. Now, you have some information. So you have some definition about header, right? You have a header here. You have encapsulation. Now you have the PDU, Ethernet Protocol Data Unit. What is the header? Let me ask you again. What is the header here? What is the header? What is the purpose of the header?
To like distinguish what parts of the trailer or what.
So header is a control information, right?
Yeah.
Control information, and you put before the payload. Okay. Good. So what is encapsulation? What's encapsulation? What's the encapsulation? Hello? What's the encapsulation? Come on, guys.
Encapsulation is adding a header to data inherited from the layer above.
Okay. And the PDO is the data unit. It's a technical term for group of bits that move from one layer to another. So basically, for every layer, they have general name. It's a PDO here. But when you go to specific layer, each of the layer they have specific name for it. For it. Now let me go to this one. What is this? Okay. So now for this one, you see here. Okay, so now you see that is the process of encapsulation and de-encapsulation here. So think about this one here. From the application, think about if you want to send out the email here. Email here. That is the payload. That is the payload. So everything here from this one application and presentation and session here. If you work in the TCP/IP, they are application layer here. It is application layer. So now from the payload, you have to send it down to transport layer. And transport layer normally is a transport layer. If the email is very huge here, you have to break it down into multiple segment here. You have to break it down in 1, 2, or 3 here, and so on. So now, when you send the transport layer, you see that is the process of encapsulation here. So we have the payload here. You have the payload. You have to put the header here. That is the control information of the transport layer. So now you have the header from transport layer. You have to send it out. You have to send it out to the network layer. Right? Again, you add the header from the network layer here. Right? And again, when from the network layer, you send it out to data link layer. Remember, the data link layer is the layer you have both of the header and trailer here. That's why you have the header and trailer here. Okay, that is the process of encapsulation here. So you can think about encapsulation. That means you have original data here. You put it into another envelope. When you send it out to the layer, you put it into the another envelope, and so on here, and so on. And that's the process of encapsulation. So you see, that is it's the process of encapsulation when you send it out the data. But when you receive the data, you have to do everything in the reverse order. That is the de-encapsulation. De-encapsulation here. That means when you receive the envelope, you have to open it. You check information, it's correct or not, send it to the upper layer. Upper layer, check information, correct or not. Open the envelope and send it to the upper layer, and so on, until you receive the original data. You see, original data here, tiny payload here, and you receive the tiny payload here. But in order to deliver the original data, you have to process the encapsulation and de-encapsulation. You have to put the header here, and you have to do everything with the encapsulation and de-encapsulation here. So you see, you have the long way. You have the long way from the source to destination here. So think about this one here. Think about if you want to send email from the sender to receiver. So basically, you see, you can have to go one router 1, the router 2, router 3 here, and to this one is sender and this one receiver here. So remember, the process of encapsulation and de-encapsulation, it has to happen at every network device. So see, for this one here, you have to put in envelope. You have to do a lot of process with encapsulation, and you send it to router 1. when you send it to router 1 here, router 1 have to do everything with the encapsulation. He have to open every envelope. He have to open every envelope here, and he knows that in order to deliver to the receiver, he have to send it to the router 2 here. And again, he have to do everything about encapsulation here and de-encapsulation here, encapsulation here, and de-encapsulation here. That is the process. It have to happen at every network device. So whenever you receive it, you have to do a de-encapsulation. But when you want to send it out, you have to do everything with the encapsulation here. Okay, which of OS silo and layer boards have the header and channel? What do you think? Which layer have the board header and channel?
Data layer, data link layer.
Here, the data layer have a board of the header and channel. That's the only layer you have a board of header and channel here. Okay, so we have some information about safety procedure and policy. You can look it on the My tab here. Okay, now I come back to the My tab to see how you navigate the My tab here. Why? Okay, so when you open the My tab, that is the interface of My tab here, right? So basically, when you have each of the module, you can click on this one, you can open it, and the first thing definitely is the learn it here. And in the learn it, you go to the read here. That is the reading you are supposed to do for every module here, right? So when you scroll down the reading, it break it down into the many sections here, and something. See at the end of the reading here. Whenever you see at the end of the reading, you have the hands-on project and the capstone project. And sometimes in the module you are required to do with the hands-on project and capstone project here. So if you are required to do with the hands-on project, you have to click on the hands-on project here. And if you are required to do with the hands-on project number 1, you have to do number 1. And if number 2, you go to number 2 here. Right? And if you want to come back to the reading, you just click on this one here, and you go to specific one here. So in the capstone project, you click on the capstone project here, and now come back here. So if you want to go to specific reading, you click on the next one. You just follow the reading with this one here. Okay, so I think that's all for the slide. Now we move to some of the activity here. Let's see what is it. Some of the activity. For the first one, you have discussion here. You remember that for every discussion you have 2 due dates here. The first one it is on. See, the first one it is on Friday, and the other one is on Tuesday next week. Now the first one it is a discussion. You have discussion here. Now when you go down, you have some of the video. If you want to watch it or not, it's the video. You have the PowerPoint as optional, but I strongly recommend you to read the PowerPoint here. And that is a link to the My tab. For the reading chapter 1 here. Now, when you go down, you see you have the sum of assignment for the first module here. You have the module 1 part 1, live virtual machine. You have part 1 live virtual machine, and you have this one here. You have the quiz also. Now, working one by one, you see what you have for this one. Okay, so it linked to the My tab here, and to do it, you just click the Start Assignment Now. So is the rate every instruction here. So on this one, you have information about the instruction here. If you have something going wrong, you can report it, or you can setting and customize the interface here. Your name, time zone, or you can change the font size here. And that is information about this one. We have some information about how to navigate the lab here. So I think it should be better you watch all the video here.
Hey everyone, it's Matt from Practice Labs. I'm going to give you a brief walkthrough and introduction to the Practice Labs platform using one of our most popular titles, CompTIA A+ 2201002. You may have accessed the Practice Labs platform by clicking a link in your education provider or organisation's website, via a learning management system or LMS, or perhaps you logged in directly using your username and password. The first thing you'll see when you land on the Practice Labs homepage will be your list of available Practice Lab titles on the left. This may include some of our major vendors such as Cisco, CompTIA, Microsoft or VMware. The list of titles you see may differ from what I'm showing here. If we now take a look at the options that are available to us across the top, the next one will be the Exercise tab, where the content for the module will be displayed once we've selected our lab title. The next tab will be Exam Prep, which you may or may not see depending on if you have any exam prep titles assigned to your account. Next is the Additional Features tab, where you can view your exam prep and lab reports. Then it's the Settings and Customization tab, where you can view and configure settings for your Practice Lab environment. And lastly is the Help and Support tab, where you can view useful documentation, user guides, support videos, and get details on how to contact our support team. Now let's jump into this CompTIA A+ Core 2 lab title. When you click through into the lab, you'll see a brief introduction and a list of available modules. When you select Module 1, Operating System Types and Features, you'll be presented with a list of exercises contained within this module. Why don't we click on the Start button to dive into this lab? This takes us to the Exercise tab that I mentioned earlier, where we can see the content you'll be working through to complete the module. To move through the exercises, use the Next and Previous buttons located at the bottom left of the content panel. Before you get into the exercises, you'll be presented with the lab topology diagram that shows you what you'll have access to during the lab. As it says in the content, you may or may not use all of the devices. We can then continue through the exercises using the lab devices we have at our disposal to carry out the tasks requested. Once finished, use the Done button to mark the module as complete. Whilst waiting for PLAB DC01 to power on, we can see there are a couple of switches on each of the other devices. Power on and refresh. I'm now going to go ahead and power on the Linux CentOS device to give you an idea of a multiple device lab with different operating systems. Located at the bottom of the lab toolbar is the lab session timer, as well as 3 other buttons: power on all devices, reset all devices, and log out. Now that the domain controller device has powered on, there are a few new switches that have appeared: power off, reboot, reset, and suspend. At the top of the lab toolbar are 2 buttons: toggle content and fit device to window. We can now look at the devices themselves in more detail and explore the features they offer. Starting with the device toolbar, we have the option to toggle auto login, switch to console mode, reconnect to the device, show some information, or hide the device from view. These options may differ though, depending on the device and lab type you're using. Inside of the device is a menu that provides access to a virtual keyboard, which is especially useful for touchscreen devices, an information panel that provides details of your connection, the ability to send a Control-Alt-Delete command, which is helpful when trying to unlock a device, and we can enable a right-click within the lab when using devices without this functionality, such as mobile phones or tablets. And that brings us to the end of this quick overview. Thanks for watching. Bye for now.
Okay. So this one is a personal setting.
In the case where you want to change your personal preferences, use the settings menu to have a look what's available to you. the settings defined in this section cover personal details, device connection details, platform details, and some basic usability options. Have a look through each of the different configuration options to see what they do by simply clicking on the help icon located next to its name. Each of these will change the behavior of how you interact with the labs, whether it's a technical basis or just simple functionality. To get the best possible experience from the Practice Lab platform, I recommend you set out your screens before you continue. So the two key areas to size correctly are on the left-hand side, the content panel, and on the right, the console view. So let's concentrate on the content panel to start with. Just to the right of the actual details, there's a small bar, which is just to the left of the tools bar, which you can drag to the left or to the right in order to get the correct viewing size for your particular screen. Once you've settled on a screen or a view that is comfortable to your own resolution, you leave that in place, and then we have a look at the console view. Now you can see the console has a couple of scroll bars, which is not ideal when you're trying to transfer the information from the left-hand side into the right-hand side. So what you can do in this case is simply click on the Fit Devices to Page Width icon, which is located at the top end of the tools bar. Once you select that, you can notice that the actual console then fits to the space that you have available to you, making it easy to display both the content and server console in one screen. Whenever you get to a stage where you want to use the labs as a kind of a standalone environment, just to test out new concepts, and you're not too interested in the content viewer, what you can do is collapse the content viewer by clicking the menu item to the left or fit to screen. What you'll see is the content view disappear, minimize to the left. You now use the Fit Device to Page Width option, and you'll notice now that you have a full desktop available in front of you for you to carry out your work.
Okay, so I think it's better that if you go to specific one here. So think about, I come back if you want to look for the instruction for this one. Next year, when you run everything, when you read every instruction here, you go to the next one. So you see, you have on this one you have the 60 minutes. So normally, if you have more than 60 minutes, it will automatically log out here. So if you do more than 60 minutes, so you can click on this one. So whenever it's going running down the 60 minutes, you can click on this one. It extend you to the 60 minutes here. Right? So think about you are now, you see, you only have 1 or 2 minutes left. You can click on this one, renew it to the 60 minutes here. On this one here, you see you have for this one for this topology here, you already have the 2 computers, and this you have this one and this one here. And when you move over the mouse, you see you have many options here. You can power off, you can reboot, you can reset, you can resuspend or refresh computer here. Think about this one here. I want to power on, I move over and I click the power on. So see, when you click the power on, it's moving to the PC here. Right now we're rebooting. Right now it's a startup here. So you have to wait for a while. Or you can click on this one if you want to power on all devices at the same time, or you can click on this one if you want to reset all devices at the same time. So see, right now the PC here already reboot successfully here, and I click on this one, and I can see what this one is a server here, and I can this one here. All right, and some information on this one. You can have some information about this one here. So see, you have the host name, operating system, username is administrator, and the password here. You see, so when anytime you log out, if you want to log in again, you have to use the password. It is the password here. You remember that one. And you have information about the IP address. So, and this one's console connection. Now, so now we come back to the instruction here. User follows the instruction. What you are supposed to do with this lab. This lab. Now, the next one. Now, that is topology. So I strongly recommend you that you have to look on the topology to know which device you have to work on this one here. So normally, here's my suggestion. So whenever you see the topology, the best time you capture the screen. Use that capture screen is tool here. Capture the screen and copy it. And you go to the Word document. And you paste it here. Paste it. So see, anytime you want to look it back, that what you have in the topology, that you look it back for this one, you know that for this one, it's very simple. You only have the two computers. The first one is 192.168.0.1, and the second one is 192.168.0.2 here. So that is the first thing I strongly recommend you to do whenever you're working with the lab. Capture the screen, capture the topology here. And sometimes you can go back to look information, to have information to answer the question. Now the next one, you see, you have two PC. Sorry, you have two PC for this one. Microsoft Windows Server, standalone here. Click next one. Okay, see, you have the two PC. You have the PC. Step one. Watch the video. I already watch it. You already watch it. Right? Now for this one, you have the content pane here. On the left, you have content pane. In the middle, you have the lab toolbar, and on the right, you have device pane here. And you can customize it on the video. See, for this one here, it already is automatically power on, but the PC2 is not, and I have to manually power on it. Okay, that follow the step here. That follow the step. That one is that when you customize your personal setting here, you can customize email or the phone size. Now the check for here. Have you watched the getting started? Yeah, right. Submit it. Are you able to resize the screen? Yes, of course. I can hear. Right? I can hear. Yes. Right? And so on. Are you able to power on device? Yes, I can power on device number 2 here already. Right? So remember, every time you have to click the submit here. Submit, right? Could you change the personal setting? Let's see. If I want to change the font here, I large. Right? I'm able to do it. Right? So, of course, I'm able to do it. Right? Manage the device. Okay, so everything on the toolbar here. That's the way you can manage the device. You can power on, power off, reboot, reset, suspend, or refresh. Power on both. I already power both here. I power both of them. If you want to power on, you can click on this one here. As right, if the time is running out, you can click on that. Renew to the 60 units. Okay. Power on. Okay, here. Okay, so now they said that you go to the PC1. Right? This one you can go this window here. Now, if you want to use the control and delete here, you have to click on this one. Right? And you go to control and delete here because it's a virtual machine here. Or you can go to the keyboard, right? Or go to the keyboard here. Alright, so think about this one, they copy the effect here, right? Copy the effect here. Copy it. And you see, if you want to paste it in the virtual machine, right? You have to paste it here. Alright, so when you paste it here, you have to click send to the remote here. Send to remote. Click the send to remote. So we can copy to the clipboard. And now, if you want to predict something, so think about this one. So if you want to, So think about I go to the contact here. Sorry, not so now it's already copied in the clipboard, right? And now I want to print it. If you want to see. So remember that if you want to copy something, you have to go to the clipboard, you print it in here, and you have to click set to remote. Question: I will go to connect device. Yes. And we will go to switch. Yeah. Number 1, number 2. Yes. I will read the system guide. You can check on this one here. See what information here. This one. Okay. So that is you want this one. This one when you log out here. You want to log out. Yes. Yes, of course. Yeah. Log out button here, right? Yes. You know what happened to your device when you log out. So when you click the log out, everything gone. And remember that you have to finish everything before you click the log out. I will take point. Screen here. So if they require you to take screenshot, you have to take the screenshot for this one. And this one is where I read it here. So take screenshot. Everything here. Next. So see, you done it. When you done everything, you submit the report. Yes, yes. When you submit the report, automatically log out. You don't have to do it. Okay. So this one is very simple here. Let me go to the second one. Some of them I have to. This one now. Introduction to the OSI model. Again, for this one you had for this one you have topology. Sorry, you have topology. Why? Tiny screen, so I cannot capture it. I want to capture it, but very tiny screen. But it should be better if you have the big screen. Okay, so just some of the review again about OSI model. You have the 7 layer and tell you a specific function of each model here. And you compare between the two models. Okay, for this one you have some device here for this one. Now they say that you have to connect to the Win10 here, right? This one, right? This one here, you have to click on the Win10. You have the power on. First one you have the power on. And you have to wait for a while. Okay, so what do we send here? And you look on the task bar, click the right network. This one is where we you have the network interface card information here. Right click on this one. You go to open the network internet setting. So when you go to this one, that will tell you that you have how you connect to the network here. You have Ethernet, you go to Ethernet, right? And when you go to Ethernet, you go to the chain adapter option here. And oh my God. Yes, sometimes it's working with the virtual machine here. Yeah. So see for this one you have two internet card here to interconnect with the network. You have Ethernet number 1. Sorry, you have Ethernet and Ethernet 2 here. And you just follow the instruction here. For this one, you have to working with you right click on this one. You go to property. So that is you just follow the instruction. It's very simple. I don't want to go in detail here. And just see what information I have to highlight to you. That is very simple. Very simple. Okay. So sometimes if you want to working with a command line interface, so in this case, if you want to working with a command line interface. So in this case, if you want to working with a command line interface, with a CMD, the command line interface, and sometimes it's not open, or if you want to run an administrator, you click the run as administrator here. Right. So now I just click the open that for here. Right. Okay. Okay, so when you open, you put IP config over here. That gives you every information about the network interface card here. So you see, for this PC, you have the two network interface cards. The first one is Ethernet, and the second one is Ethernet 2 here. Right? So when you look into the information here, you have a lot of information. The first one, you have the physical address here. That is data linear address. You have the IP version 4 address. 192.168.0.5. See this one here? Not there. This one here. 192.168.0.5. That is here. And it has a subnet mark. We'll learn about what is IP address, what is the subnet mark, what is the default gateway later on this class here. But for now, you know that in order to check information about the IP address setting, you go with the IP config and a /o here. And that's the second one here. So see, and you have this one is ARPR. So sorry. ARPR, sorry. ARPR is that it's a reverse table. It keeps you the matching between the IP address and the physical address here. So whenever you send to the 192.168.0.2, the computer knows that in order to send to 192.168.1.0.2, we have to send it to the physical address here. That's why you have to catch to store the matching between the IP address and the physical address. Okay, And that in case that if you want, sorry, oh, sorry. The same with the computer, right? So if you want, sorry, if you want to do something with the IP address, you just click the network setting here, right? You go to Ethernet, you change another option. For this computer, you already have one Ethernet here, so we go to property and see with the property here. If you want to change the IP version 4 address, you click on this one. You go to property, and right now it's automatic that working with the DHCP. But if you want to change it manually, you are able to change it from here. The same with the lab. The lab actually is working the same. Okay, so that in case you want to change the IP address, you just follow, you just follow the step here. You change the IP address. You go to the property here. See, you go to the internet, go to the property, and you go to the IP version 4. Click on property, and you change. Enter the IP address here. So when you have the IP address, you are able to communicate with the other. So you can check it. You can add the root and can ping it to see if you're able to ping it or not, right? Or asking you to take a screenshot to do it. Let's see what you have to do with this one. This command is to tell you what is session you are right now. For the TCP, I see for this one you have many sessions going right now on the TCP, and for this one you can check on the UDP also, TCP or UDP also. And for staff manager, you can control every running application right now. See, you have many applications right now, and it tells you what that how many percent of the CPU and how many percent of the memory each of the specific program account for. Okay, so I think that for the module 1, it's very simple. You just follow the step in instruction to do with the assignment. So I don't have to help you much with the module 1. And the last thing with this class here, I want you to check. I want you to check the email sent from Net Academy, and I want you guys to create your account in order to log into the Net Academy. So in the case of the Net Academy, so in the case of Net Academy, you go to the Net Academy. You will see you have class here. You have the NETI 104 Spring 2021-22 and introduction to the package here. I can check here right now. So some of you already logged in. I can see it here. Some of you already logged in, but some of you not. So anyone is not, please check your email. Send from the IBTech email and create your own account here. You have to do something with the packages for this one, and that's why you have to go to the NETI 104 introduction to the packages. And one more thing, you have to go to the packages chaser resources. Go to the packages download page. Scroll down, and if you are Windows, download this version. Download the Ubuntu version or Mac OS version here. And let me see, I have it. Yeah, that is the interface of package chaser. Okay, so that is the interface of the packet chaser. Packet chaser is a simulation program. It simulates how the network work together here. So I keep my login for 3 months. I log in with my information account here. Okay, so that is the interface of the packet chaser. That is simulation program, and you are supposed to do with some assignment on this class here. So when you look on this one, you see on the down here, you see the network device here. The network device. So in the network device, break it down some of the category. You see when you scroll down, you have router, you have switch, you have hub, you have the wireless device, you have the security firewall here. Right? So you see, is that the network device? Think about this one. If you want to build your own topology, you can click on the router and you just drag and drop here that you want to build one router for this one. Now, think about you have you are on the local area network. You need one more switch. You have 2960 Cisco switch here. Right? So now, sorry. That the first one is the network device. Right? Network device, you have the router, you have the switch, you have hub, the firewall. The second one is end device here. End device, you see, break it down furthermore into subcategory. You have end device, you have a home, you have smart city, you have the industrial, and you have the power grid here. So basically for this one is just working on the home, end device here. And the end device, you see, you can have the PC, you can have the laptop, server, or a printer or IP phone here. So think about if you have 2 computers, drag and drop 2 computers here, right? Now, the third one is the media here. See, it's a connection here. The connection is how you interconnect them together, right? So it's a connection. You have automatic. You have the console. You have the chat through here. So basically, for this one, you working with chat through cable. You just click on the PC. You go to Fast Internet, and you want to plug in the Fast Internet 05 from the switch. Click on that. Again. Look on this one. I want to click on the 10 for this one. That is how you interconnect them together. And for this one, I said interconnect from the 20 to the interface of the router. Right? And that is a logical. You see, that is a logical topology. And if you want to see how physical it works, you can click on the physical. Right? So we see on the physical here. You see how it works, how it's interconnect them together. You have the 2 PC, and you have the switch here. You have the switch here for this one, and you have the router also. Very, very straightforward. And if you want to go back to the logical, you click on the logical. And think about if you want to convert for the PC, you have the 192.168.1.10 for this one. And I put it 192.168.1.10 for this one. And now, so this one is 192.168.1.10, and this one is 192.168.1.20, and they are on the same network. So I'm able to bring together. So I just take 192.168.1.22. See, I got reply from the other PC. That is everything about the very, very straightforward example with the packet chaser here. So now I think that's the time for you to watch some video about the packet chaser. You do it on the
Hello everyone!
we'd like to introduce you to an exciting and easy to use network simulation tool, Cisco Packet Tracer. This simulation tool provides amazing features allowing you to build networks from scratch, open sample files from pre-built networks, test new and existing network designs, and even examine how data flows through your network. Now, you can build networks that include servers, firewalls, routers and switches, and even wireless connections. But with Cisco Packet Tracer, it doesn't end there. Packet Tracer provides support for the Internet of Things. In the IoT, known as Internet of Things, devices and sensors that have never been connected before are now being connected. So look at the example I prepared here. This beautiful house has multiple devices connect to the network. Now, I was just playing around with Cisco Packet Tracer, and I've added smart lawn sprinklers, smart ceiling fans, smart door sensor, a smart thermostat, even a water level monitor, and a garage door. And they're all interconnected. We can even set up a wireless router and switches and laptops, firewalls and computers, and new devices called our Smart Home Gateway. With Cisco Packet Tracer though, we could either start from here, that blank screen, and build it from scratch, or we can even open up pre-built sample labs. These are pre-built sample labs with pre-built networks. To do it, we'd go to File, and then Open Samples. Within, we're going to have a list of multiple folders where we can browse through different labs. In each of these folders are pre-built sample labs. For example, we have server labs. And in the server labs, we can see security with AAA, DNS, file servers, secure web browsing, email servers, and even go into IoT registration servers for our IoT devices. For now, we're going to head over to the PC directory and then the VPN folder. In the VPN folder, there's a VPN easy file that we can open up. This file gives us a basic VPN connection that we can test within Cisco Packet Tracer. We can follow the instructions to deploy our own VPN. Now, Packet Tracer is not a replacement for real physical equipment, but it's an excellent tool that allows you to build and model your own configurations. It also supports a lot of the technology required to practice for your Cisco certification exams. And good news, Cisco Packet Tracer is free of charge. This tool is available for both Linux and Windows operating systems. It's even available for mobile devices like smartphones and tablets. There's so many areas to explore in Cisco Packet Tracer. The best thing you can do right now is download and install the latest version and just start playing. The opportunities to learn technologies and